If you get a question that says prove, you must simplify the left hand side or the right hand side separately. Start with the more complicated side. So in this case, prove that tan theta plus cos theta over 1 plus sin theta is equals to 1 cos theta. These are your typical questions that you need to prove. So we'll start off the proving by firstly writing left hand side. Left hand side. Let me just erase that. Hey, the pen is making me mess up today. My game is not strong. Left hand side, right? So this is what we'll be dealing with. We'll be working out the left hand side because it's more complicated. 10. So with 10 here, you can use square identities, right, to reduce or expand. So in this case, 10 is the same as sin theta over cos theta, and plus we'll keep this as is, cos theta over 1 plus sin theta. So once we get to this point, we can see that we have fractions, right? And there is a plus sign. So since we cannot divide or we cannot cancel over a plus and minus sign, because we could cancel this, someone can actually think that it would be okay for them to cancel cos theta with that cos theta over there, sin theta with that, but it's not possible. We need to firstly come up with basically the lowest common denominator. So the lowest common denominator, which we are going to keep, the LCD in this case would be both your cos theta and the 1 plus sin theta. At this point, we then start using our lowest common denominator. How many times does cos go into that? So cos cancels that, and we are remaining with the. So let's just answer that. Sin theta. Okay, let me erase that. Hey, the pen today, you are not kind. But anyway, sin theta in brackets. Since cos cancels the cos, we are remaining with 1 plus sin theta, close bracket, and then plus the plus sign. So how many times does 1 plus sin theta go into cos theta, 1 plus sin theta? So this, clearly we will be remaining with the cos theta. In brackets, we will have our cos theta as well. So now that we are at this point, remember we keep the LCD, which is your cos theta 1 plus sin theta. Okay, so to solve this further, we need to multiply into the bracket clearly, right? So we'll have our let's just try to group it. We'll have our sin theta times 1, which will give us sin theta, sine theta times sine theta, which will give us plus sine squared theta plus cos squared theta, cos squared theta, right? All over our LCD, which is cos theta 1 plus sine theta. So at this point we can see that we have a situation where we can use square identities to reduce, right? So remember that sine squared theta plus cos squared theta is equals to 1. So this is according to our reduction expressions, right? Reduction formula. So we can change this to 1, so we can have here above sine theta plus 1 instead of having sine squared theta plus cos squared theta. So plus, okay, let me put the plus, okay, let me erase that. Okay, clearly the pen is not on my side today. Okay, plus 1 all over, oh, this was the 1 here, all over cos theta 1 plus sine theta. I hope you can see what I can see. So at the moment I can see that 1 plus sine theta is the same as sine theta plus 1. You can say 1 plus sine theta literally above here. So I can actually say, how many times does sine or 1 plus sine theta go into this? Once, right? So 1, how many times does it go there? Once as well. So you have your 1 over cos theta, which is the same as the right hand side. Therefore you can have your R, let's rather have it here, RHS, right hand side. So it is equal. So you've proved everything, and then this is it. Thank you for watching.